Let's solve this problem from the AMCA. 3 concentric circles at O have radiuses of 1, 2, and 3. Points B and C lie on the largest circle. Okay, we have these shaded regions, as you can see. And they're also, basically we have this annulus here, but then we also have this additional piece. There's basically 2 pieces here. And we're asked to find the measure of this angle BOC. So the first thing to realize is, okay, 1, 2, and 3. Essentially, we're dividing our circle into 3 regions. We have region 1, inner circle. We have region 2, that's between the first circle and the second circle. And we have region 3, that's outside the second circle, but inside the third circle. So let's calculate the area in each of these regions. Okay, so region 1. I'm just going to shade it in green. What's the area of region 1? Well, that's pretty simple. Pi times 1 squared. That's just pi. Okay, region 2. What's the area of this region? This is a little bit more involved, but still not that complicated, right? So we have the outer circle, which has an area of pi times 2 squared. And then we subtract the inner circle, which has the area of pi times 1 squared. And that's 4 pi minus pi, which is 3 pi. And finally, we have the outermost region. What's the area of this? So we do the exact same thing, right? Pi 3 squared minus pi 2 squared. That's 5 pi. Okay, cool. So now we have the area of each of these regions. So the outermost one is red, middle one is blue, and inner one is green. So I'm just gonna erase these things for now, but you should know that this is like the order of those 3 regions. So now what is this gray area? Well, like I mentioned at the beginning of the problem, we can divide up this gray area into 2 pieces. One is just the entirety of our middle blue region, if you remember, right? We can divide it up. That's just the entire blue region that we marked earlier in blue. So we know that part all has the area of 3 pi. So let me just draw that. This whole region here, we calculated has the area of 3 pi. But now there's an extra piece, and it's this thingy over here. Well, now what is the area of that? And this is like the tricky part of the problem. So it's 5 pi. But then now we have to multiply by the angle of BOC times divided by 360, right? Because if you think about it, this is like the fraction. Remember, the area of the entire outer region that we called red was 5 pi. And this over here is just a fraction of it. So what fraction of the entire region is this? Well, we just multiply by whatever this angle is over 360. So we multiply 5 pi times angle BOC all over 360. So we're asked to solve for BOC. So if we can somehow figure out what this area is supposed to be, then we can solve for BOC. But now we look back at the problem. Shaded and unshaded regions are equal in area. So in total, in this entire circle, the entire circle has area equal to 9 pi, right? Pi times 3 squared, which is 9 pi. So if we want the shaded regions to make up half of that, it has to make up 4.5 pi. So then we have that, okay, we already calculated 3 pi is always shaded. So 3 pi plus 5 pi times BOC by 360 equals 4.5 pi, because shaded region is half. So that's 5 pi times BOC over 360 is 1.5 pi. Or now we can solve for BOC over 360. We divide by 5 pi from both sides. And we get that BOC over 360 is 1.5 pi divided by 5 pi. And that's just 0.3. So BOC is just 0.3 times 360. That's equal to 3 times 36, which is 108. So our answer is simply 108. I hope you enjoyed this video.